Hi everyone, in this video we will have a look at finding the derivative of the function a to the power x. And we want to find the value of a so that f of x, a to the power x, is its own derivative. So f dash of x is the same as f of x is a to the power x. Now we'll use GeoGebra to do that. And I've got this widget here. What we see here is the blue function a to the power x, and the red function is f dashed. So that's the derivative of a to the power x. As you can see, they're not the same. But I also have a slider with a, so I can change the value of a, and I can see whether I can find a value for which both the blue and the red one are the same. And there I found it. I can overshoot it. There's only one value for a that makes it the same. So apparently the value for a is 2.71828. As you can see, 2.71828, which is the number e. E is Euler's number, and normally it is found by taking the limit of n to infinity of 1 plus 1 over n to the power n. With n approaching infinity you get Euler's number, and Euler's number is very special because for this number, when f of x is e to the power of x, the derivative is the same function. Now in the second part of this video we will have a look at the derivative of sinx, and that one's here. So here we see the function sinx, and we know that the tangent to the function, the slope of the tangent, is the instantaneous rate of change of the function. So that is a measure for the derivative. And I can move my point A about, and we can see that the tangent here is 0 at the top. The slope of the tangent here is -1, 0 again, +1, 0, -1. So this instantaneous rate of change, I want a function for that, the derivative function of sinx. So what we can do is trace that slope value. And notice that it starts at 1, and then it goes down to 0, all the way down to -1, and then it comes up again, back to 0, etc., etc. And you can see what function gets its shape here. It looks like the sine function, and it is, but it's shifted a little bit. It is shifted exactly pi over 2, which makes this function the cosine function. So the derivative of sin x is the cosine of x. If f of x is sin x, f dash of x is cosine x. The other way around, if f of x is cosine x, the derivative is negative sine of x, mind the negative. Just to make things complete, if the function is the tangent of x, its derivative is 1 over the cosine squared of x. We're not going to look at that, but that's the derivative. In other words, that's the secant squared of x.